Johnny? Oh, this brother.
All right. Yes, Ethan. No.
What? How much
I'm so hungry yet.
That's wonder we're hungry and cold.
I didn't eat breakfast this morning. Yeah, I'm never gonna remember to get your Cheetos.
Huh?
I will never remember to get your Cheetos if you don't remind me.
It is Cheetos.
Thanks.
That was helpful.
Hey, give me my stuff.
Johnny, do you need me to remind you?
Yeah, you got it.
What do you have to get?
Cheetos.
Cheetos. Well, I remember my phone, so that's gonna be.
You got it back.
Oh.
580.
So yeah, I'm still grounded.
Are you guys literally still writing this in?
No, I'm not. We should bring in figures.
They're like,
Well, it's not bad.
It's what Cassie just said. What's it called?
What's that mean?
No.
Nutri-Grain?
Yeah, Nutri-Grain.
Oh.
Yeah, it's just clear bills, but short and
Gosh.
yeah, but fill it fruit filling, it's all fruit filling. Where's Andrew?
Ooh.
Great.
My camera, my sister fixed her shoes with tape today. Wait, that one? Yep. What'd she do? I don't know.
Okay, don't do that.
Great.
Oh, it's gonna be fun.
That's up to you. I mean, when he gets you naked, I'm hoping. So, you might be able to answer this question already that they pose up here. But early on, when scientists started to think about motion, they believed that things tend to stop if left to themselves. And this should make pretty logical sense, because if you take an object and you let it go, if left to itself, what does it do?
Stop.
Wait for it.
Well,
There you go. It stops. So, scientists, way back when, saw this and said, well, if left to themselves, they stop. Is that a true statement?
I think so.
Yeah, it is a true statement, but, you said but,
I said, yeah, but no.
okay? What do you mean yeah, but no? What do you mean by that?
Because they need like gravity or friction and stuff.
Yep. So they were right that objects, if left to themselves, do stop, but what they were kind of wrong about is it really left to itself? Because what's acting on it?
Gravity.
Gravity,
Air.
air, friction, all that stuff is actually acting on it. So, this is true. Objects do stop if you quote unquote leave them to themselves, but it does not mean that the objects stop by themselves.
But wait, so like if you put something in our space, doesn't it
Well, there isn't no gravity. There's just very little gravity. So, yes, it would continue to move. Like if you were in outer space and you fell off the spaceship, you would float on forever. I mean, yeah. I mean, eventually you might get close enough to like Jupiter or something where it would attract you to it and you'd slam into Jupiter and burn to death. But
Oh.
What if you're?
But you probably would pass out for lack of oxygen first. Hence why you can kind of float in outer space. Right? You ever seen those videos of astronauts, you know, flipping and doing all that fun stuff? That's because there's no gravity pulling them to the ground, so they essentially just levitate. Object in motion stays in motion. Or don't. So remember, guy before Galileo was Archimedes. He did what? Wrote about forces. Then Galileo came along and defined it, did some experiments on it. And we have 3 laws that are from Mr. Sir Isaac Newton. But we can't really give Newton all the credit because a lot of what he came up with wouldn't have been possible had not Galileo made some really important connections. Yeah? I think so. I don't know if I've ever had anybody do it, but in theory it's a pencil, right? Okay, probably okay then. Just whatever you do, don't slam pens in there.
I'm running out of ink. I'm going to sharpen my pen.
I'm running out of ink, gotta sharpen my pen, yeah.
My Sharpie is not working.
Don't worry, no, everyone's staring at you awkwardly. Okay, so we're not going to get into all the various details about Galileo's experiments, but I just want you guys to know that if it wasn't for Galileo, Newton would not have probably come up with what he did and with the laws that we give him credit for. From his experiments, Galileo stated that objects really do not want to stop. So actually I would say that Galileo should be given a lot more credit than maybe he does, because he was the one who called this idea inertia, and Newton's first law is known as the law of inertia. Sounds to me like Galileo pretty much came up with the law without getting credit for it. So when you read number 1, it says Galileo concluded that objects have no tendency to stop. What does that mean? They just don't want to stop. There's no other way of wording that, huh? Okay. But another way of saying this is that an object would continue to move indefinitely. But we know in reality that do objects continue to move indefinitely? No. So obviously that's going to lead Newton to be able to come up with his first law. And in order for it, if an object has no tendency to stop, what stops it? Something else. Some outside force is causing objects to stop, because basically all objects are, another way of putting it, are lazy. They just want to do what they're doing. They don't want to change what they're doing. This idea is called inertia, and I want to define it for you. It's in your vocabulary sheet. So if you pull out your vocabulary sheet, you should have a definition of inertia.
Desire.
I want you to put that in your notes somewhere so that you see it in a multiple places than just in your vocab sheet. Someone read it for me. Mara, you started. Go ahead and say it again.
Desire when object is resist the change in motion.
Basically what that is that all objects want to do what they're doing. That's called inertia. You guys all experience inertia every single day. Okay? How'd you guys all get to school today? In the car. Okay? You experience inertia every time you're in a car. Why do I say that? You don't have any idea what I'm referring to. Doesn't want to go. What was that? Sure. Okay. Yeah. Anybody, when you're in a car and someone drives around a corner or takes a left turn or a right turn, I'm going to say they take a quick left turn or a quick right turn because it makes it more obvious. What happens? Now the question is, when you do this, are you moving that way? No. Well, when I did that. But when you, when you're in the car and that happens and it appears like you're going one way, do you know you're actually not going that way?
What? Oh.
This is going to be like a top view of a car. I realize that this probably doesn't do you much service here, but
Thank you for that.
I realize I have a top view of a car and a side view of a person. But anyways, okay? So we got our road, and this car is too big for the road. All right. Anyway,
That's the motorcycle lane.
The road is uneven.
I don't think you should work for the DOT.
That's a beautiful drawing.
No, it looks pretty much like the.
why do you act like this? I'm not a great drawer. Why can't you just focus on what I'm trying to show you? When you make a left turn, what does your body want to do? Oh. Your body wants to stay going straight. It wants to resist a change in motion. So really what's happening is your car is moving underneath you, you're continuing to go straight, and that's why it feels like you're going this way. Imagine, right? When you take a left turn, which way do you go? Do you go towards the door, or do you go towards the middle of the car when you take a left turn? You would go towards the door. If you took a quick left turn, you would go like this. Okay? And the reason why is the car is turning, which is causing you that wants to go straight to hit the side of the car. Okay? What happens when you step on the brakes really fast? What if you didn't have a seat buckle on? You would go through the windshield. And the reason why is you are just like any other object. You want to continue doing what you're doing. So if you're moving, you're going to continue to move unless some outside force stops you. AKA, hopefully your what? Seatbelt. Okay? Second line of defense, hopefully a few other things before you get out of the car. Yes?
Yeah, for that, how do you do that turn? Is there like, for the rickshaw on the right side?
So usually what stops you from going right, like obviously if you had the door open and you, in theory guys, if you had the door open and didn't have your seat buckle on and you took a left turn, you'd fall out the door.
Oh.
Kind of weird, right? But sometimes you're like, well, I don't always go right when I go left. Well, sometimes you tighten up your muscles, which causes you to not, like that's the force that's causing you to continue to go with the car. Right? Or the friction between you and the seat of the car. Or the seat buckle's friction on you. Okay? Otherwise, I'm not calling you guys all fat. I'm just saying. Alright? Inertia is this idea that an object will continue to do what it is doing unless some force causes a change in motion. Oops. So Newton will continue to work based off of Galileo, and he was the one given credit for the 3 laws that we will talk about. We will only talk about the first law today. We'll talk about the next couple laws in the next couple days. I'm not going to say anything more about this. I think I've already exhausted the Newton-Galileo idea. Alright, here's your first law. Notice it says inertia up there. Another name for the first law, Newton's first law, is called the law of inertia. If you need to write that down somewhere, do it. Okay? You might hear me call it the law of inertia. You might hear me just call it the first law of motion. Or Newton's first law. Everybody's heard this. Anybody never seen or heard this before? Okay.
The wall.
This law. You've never heard it or seen it? Really? Objects at rest stay at rest.
Oh, yeah, I seen that.
Hey, what do you think I was talking about?
I've never seen the word.
Hey.
Oh, inertia. Okay, gotcha. A lot of Newton's first laws, they summarize and they say unless acted on by an outside force. I specifically say unbalanced force, and the reason why I say unbalanced force, if you were moving at a constant velocity and I applied 2 equal forces in opposite direction on you, your net force would still be 0, and you would still be doing the same thing you were doing. Like if you're moving, the only way to get you to stop moving is to exert an unbalanced force on you. If I exert 2 forces that balance each other out, is that going to change your motion any?
No.
No. And we talked about what balanced forces do. Virtually nothing. Okay? So, when an object is at rest, it wants to stay at rest, and it will stay at rest unless something causes it to move. An object that's moving will continue to move unless something causes it to stop. Now we know whenever an object is moving, it does come to a stop because usually everything has what type of force acting on it? Friction, or, and even, you guys know air resistance is actually just a friction force? Like air resistance is just the air molecules rubbing against you and causing friction. It's weird to think about, but you got gas molecules bombarding your head every second of every day. Okay? Now, inertia is kind of, we can define it, but it's hard to quantify it. So it can't be like, oh, this is inertia. There's no like unit for inertia. There's no way to measure inertia directly. So a lot of times when we talk about inertia, we primarily say it has a lot to do with the mass of an object. Alright, you smart freshman thinkers, you. Why do you think the mass of the object is so closely related to inertia?
Because sometimes the bigger an object is, the slower.
Okay?
Like the bigger it is, the harder it will.
Okay, well, harder what?
Harder go towards that.
Okay, so remember what the definition of inertia is. What is it? Okay, so an object that doesn't want to change its motion. If you ever come across a situation where it's harder to stop a bigger object than it is to stop a smaller object? Have you ever come across a situation where it's harder to start moving a big object and it's easier to move a smaller object? Okay? It's because the bigger object resists more. That make sense? You ever made a snowman or a snowball so big that you couldn't push it anymore?
Yeah.
Yeah, I remember when I was a kid, me and my brother we would roll, we'd try to make the biggest snowman you could possibly make. And so like, I couldn't push it by myself anymore, and so both of us would push it until we couldn't push it anymore. And then, we'd make the rest of the snowman. But the reason why is as it gets bigger, as its mass grows, it resists moving more. Okay? So the bigger the mass, the more the object resists a change in its movement. Either it's harder to get it to start moving, it's also harder to get it to stop moving. How many of you are in football? That's embarrassing. Then you will never have experienced getting hit by a big guy versus getting hit by a small guy.
Cool.
What?
Cool.
Cool. I don't have to worry about that. All right. Well, then I can't apply this. What's another word for equilibrium? Equal. And in this case, equilibrium is referring to it's going to continue to do what it's doing. Daniel actually pays me back when he uses calculators. That's a reminder.
Wait, you want one of those guys?
I mean, these aren't my favorite, but I'll accept them if that's what you want to dump on me. I'd preferably just get a calculator. That second bullet point up there. If any unbalanced force acts on an object, it will change its motion. Isn't that what we talked about yesterday?
Yeah.
What's another word for change in motion?
Delta X.
Displacement.
What's another name for changing motion?
Hold on.
Oh, I know this.
When you change your motion, you are what?
Acceleration.
Accelerating.
Nice. Hey.
Ooh. Way too obvious of a question that you didn't think it was that simple.
No. Yes.
Didn't we talk about if you have unbalanced forces, you're what?
Accelerating.
Accelerating. No matter what. Unbalanced force, you're accelerating. Okay? Also known as a change in
Motion.
motion. Okay? That's nothing new. It says if the net force of an object is 0, that means you have balanced forces. If you have balanced forces, you are said to be in a state of equilibrium, which just simply means you're going to continue to do what you're doing. Okay? So if you have balanced forces and you already weren't moving, you're going to continue to not move.
Oh, yeah.
If you have balanced forces and you're not moving, you're going to continue to not move. You're at equilibrium. Or if you're moving and you have balanced forces, you're going to continue to move. You're at equilibrium. You're maintaining your state of motion. That's what equilibrium means in this context. Okay? And then that bottom one just says, it doesn't matter what the forces are. If they're balanced, you are not going to accelerate. If you're unbalanced, you will. All right, last slide. Look at us. Made it a silent ball?
Is that crazy?
Thanks a lot.
I don't know.
You know how many opportunities you've had?
Oh.
Well, with all the Chinese students, there's like no room.
I feel like it's
Speed round.
What'd you say? Because it is.
Oh no!
Don't eat that.
Don't eat it. Please don't eat that.
Why do you have your rule?
Disgusting.
Dude.
You know where our shoes have been, Craig? Some of us
From the
have walked
storm.
through dog.
Oh, please stop. You just
I
ate.
have kids, it's way worse.
You just ate poop.
Remember the spit story?
Disgusting.
My son, I
Oh,
probably shouldn't say this, but I'm not gonna.
Say it.
My son used the bathroom, number 2, came out of the bathroom, saw my glass of water with ice in it, and started playing in my water, grabbing my ice. I said, Titus, did you wash your hands? Nope.
Okay, so you can
So- And no, I didn't drink it. But
Oh, okay.
I'm sure there's been times where I maybe didn't know that my son had just pooped. And he put his fingers all over something I ate. Do you guys know on average you guys eat 4 spiders a year?
please don't say that.
As long as I'm doing 7 per night.
Maybe it's 7. Like when you sleep, your mouth is open.
No.
Yes! Yes!
That's a lie.
It's so true.
You're such a lie.
Break your pinky toe 25 times a
They
year.
don't like when it said people's mouth because it feels like a predator to them.
Thank you, Abby. Thank you.
Why is that? Why did everyone say that?
Record yourself with the turn.
How do they know it's a predator? It's like a moist environment.
No, it's not true, dude. It's true.
I think it is. I think it's true.
Ooh, I'm moist cake.
Yeah, like your tongue is pretty chunky.
Stop. Oh, what's this stuff? Spider web in your
I
mouth.
lied.
Eating
You don't actually eat it. They just come in your mouth and use the bathroom.
Stop.
Oh, wake me up with a spider in your mouth.
Dude,
Well, I don't believe you can stop.
Spider poop in your mouth.
Or a spider web in your mouth.
Alright,
Good thing is it
I got chills.
I can do at some point.
Spider drowns when you're drooling.
Now listen, how do you know you're asleep? Alright,
Oh my god.
okay, I summarized everything that we've talked about today. Basically, the whole idea of Newton's first law is this concept of inertia. Okay? That all things do not want to change their motion, which simply means they want to continue doing what they're doing. Well, why then do things not always continue to do what they're doing? Because there's an unbalanced force that causes a change in motion, also known as acceleration. Thank you. Okay? Also, inertia is not something that you can necessarily quantify or measure. It doesn't really have a unit, but it's very similarly or very closely related to an object's mass. Why do I say that? Common sense, everyday experiences tell us more mass, more inertia, or essentially, the bigger the object, the harder it is to change its motion. Either to get it to start moving or to get it to stop moving. Okay? Any last questions?
Oh, it is warm.
Have a minute.
My word, but she can
There's a problem.
Kramer, that is so not bad. That's a Wednesday, bro.
Oh, that is a Wednesday.
Oh.
On Valentine's Day, Mr. Kramer.
Oh my gosh.
What are you gonna say?
I don't care.
Happy Valentine's Day. It's
It
not
is.
gonna come tomorrow.
Just don't want to do it tomorrow.
Here's my homework.
It's not really. Why did you tell me that?
This is June.
Only 7. Only 7.
The look and feel.
What hours am I free? 6 period? Yep. Hey, what are you doing?
Nothing.
Uh-huh.
Nice. Russell was on the
I don't know, I wouldn't be super disappointed if they lost. I'd be fine either way. Really?
Yeah.